Hello. Hello. Good afternoon, dear students. You are welcome to this another lecture on EduSat, and our topic for today is the limit gauges. In our industries, it is very important to control the sizes of different components, and one of the methods for checking these dimensions is by means of conventional measuring instruments. For example, the vernier caliper and the screw gauge. You are very familiar with this instrument. This is a vernier caliper, and the component is held between these two jaws. One is a fixed jaw and other one is the movable jaw. So, this movable jaw slides and adjusts according to the size of the component. But this means of measurement for controlling the dimensions is not sufficient. It is very time consuming. So, we need some other alternative methods to control the dimensions of the components that are produced in the industry. Why we need to control all these dimensions of the different components? The reason is interchangeability. When we go for a spare part, suppose a part is required to be replaced in the car or your motorbike, the part should fit well over there and it should function well over there. So, for that reason, the dimensions of those components are required to be accurate and within the tolerance. So, with these conventional measuring instruments, the measurement is cumbersome and it is not easy to do and requires lot of skill. So, these advantages are there, for the reason of which we should be using the limit gauges. As we progress in our lecture, we will be finding out about all those limit gauges. So, another easier method of taking the external dimensions is this another instrument. In this, for external sizes, we hold the component between this space and take the reading on this thimble. So, with this also the measuring of dimensions is easy, but it is not as fast as is required for the production job. If we are producing say 5 to 10 items or 20 items, 20 components we can say, in that case we can of course measure with these instruments. But what do we do when we are manufacturing say 1000 pieces every month or maybe 1000 a day? So, in that case it won't be feasible to take all the dimensions. For example, I am showing you one spindle over here. In this spindle, this part, we can see there are so many dimensions to be checked. These may be going into some bearing surface. So, the sizes over here you can notice number 1 size, number 2 size which is to be controlled, number 3 size, number 4 size over here, number 5 size over here and number 6. So, it won't be feasible to measure all these sizes with help of conventional measuring instruments, as these measuring instruments are very expensive as well, and we cannot do the measurement with these instruments because there will be some wear and tear in the instruments, but these should be actually used for inspection. For example, this spindle has to get attached in this bearing. So, we need a proper fit at this place, and this will be going into this bearing, and the fit should be proper. In order to produce large number of parts with interchangeability, we need the limit gauges. The limit gauges may be for slots and holes, and they may be for male parts, that are the shafts or axles. Before starting with this lecture in detail, we will be discussing on some figures which I would like to show you. In this figure number 1, the part which is to be produced is the mating part, which you can see on the screen on your left hand side. and the hole which is already manufactured, which is bush in the middle. On the right hand side is the standard gauge. So, in this figure we can see the dimension of mating part is 50.1, whereas the diameter of the bush hole is 50 mm. So, we can see easily that this part is an interference fit part. So, in this case the standard gauge, a standard gauge is exactly the same as the part which is to be produced. So, over here with this standard gauge we can't check the size of the hole, whether the mating part is produced right or wrong. So, this is one of the discrepancies, for the reason of which we go further for not using the standard gauges and rather we use some other limit gauges. In this figure number 2, you can see two types of gauges. On your left hand side is the go gauge and on the right hand side is the no go gauge. So, for this hole produced, the go gauge should be able to enter into the hole, whereas the not go gauge which is placed on the right hand side is larger than the hole by this surface, this area over here which is shown hashed, and this not go gauge is slightly bigger than the hole. So, it will not be entering into the hole. So, we will be able to find out what parts have been manufactured right, what holes are produced rightly and which ones are produced wrongly. They should be within the tolerance of go gauge and the no go gauge. The go gauge is the smallest size that is permissible and not go gauge is the higher limit, and the hole should not exceed the not go gauge. The not go gauge should not be able to enter into the hole over here. And for the shafts or the external parts, we have this C type of go and no go gauges. The go gauge for the external parts is slightly having higher gap than the not go gauge. So, this is the tolerance in this area, hashed area shown over here. So, the sizes of all the shafts should be slightly larger than the not go gauge and slightly smaller than the go gauge gap. Next we see some type of the types of different gauges. Over here we can see the first gauge shown is internal N type gauge, in which the handle which is in the middle over here, the gauge has to be handled from the middle, and on the left hand side you have the go gauge side and on the right hand side you have the not go gauge side. For this kind of design is used for smaller limit gauges, whereas if you are having bigger size of limit gauges, for that we can choose for this second design, which is having renewable N type of limit gauges. In this go side is on the left hand side and the not go side is on the right hand side, and these not go and go sides can be replaced. After this is worn out or damaged, this can be replaced. So, that way it makes a convenience that if the go gauge is not according to proper dimensions because of the wearing out, you can only replace the only go side, while the not go side is in function as it is having the exact dimensions which we require. So, it is easy to replace one of the sides which has got damaged or worn out, but in the case of integral limit gauges you can't replace the ends. And third figure is for hollow N type of gauges. You can see on the left hand side, the go gauge side, you see a hollow over here, this cavity is formed over here. Again on the right also you can see a cavity is formed over here. The reason for making these cavities over here or hollows on both the sides is that when you are measuring dimensions for bigger size than 65 mm, in that case the gauge, the go and no go gauge will become heavy, So that's why this some material has been removed from it. So this is also a renewable N type of gauge, and in this you should note down that on the left hand side, which is showing the go gauge, the length of the go gauge is slightly higher than the not go gauge, because this go gauge has to pass through the hole, whereas the not go gauge is not going to get into the hole. So similarly, there is another type of limit gauge, which is the progressive gauge, progressive type, which is shown in the last. So the first part on the left hand side is the go side, and there is a small groove in between, then starts the not go gauge. So the part can enter up till this limit. From the left hand side, it can enter only this much, and this not go gauge will not be entering the part. If it enters, that means that part is to be rejected. In figure 4, we see gauges for the external sizes or the male parts. So over here in figure number A, you see double ended snap gauge. On one hand, on the left hand side you can see the go gauge, on the right hand side you can see the not go gauge. So the space in this go gauge over here is slightly more than the not go side. Then you can have, for these external dimensions, you can have a progressive combined gauge also, in which the first portion is the go side and the next portion is slightly narrower over here, and as such this is the not go side. Then you have adjustable gap type of snap gauges. In these, this anvil over here can be adjusted. So suppose you are measuring parts for 100 mm, they may be measured with this type of adjustable gap snap gauge, or again you may need these for measuring 104 mm. Again this anvil can be adjusted according to the situation. The first anvil is for go and the second anvil is for the not go gap. So in this case you have the flexibility that you can adjust it according to your requirement. The parts size may vary a little between the two batches. You can do batch 1 with this. With adjustment you can do the second batch or second component or the second size also with this type of adjustable gap snap gauge. Then another one over here in D part of the figure 4, you can see ring gauge, and the in this ring gauge you have one for the go type and the other for the not go type. In the go type of gauge, the hole is slightly bigger than the not go side. So we have just discussed regarding the design of different limit gauges. Now again we come on to theoretical part, why and how we need this limit gauges. To understand go and not go gauges, it is important to understand the terms interchangeability, tolerance, limit and fits. So what do we mean by interchangeability over here? Suppose the lever of your clutch of your motorcycle is broken, you will be buying a new one and you will be fitting that in your motorcycle so that your clutch works again. This happens because of the interchangeability. The companies which are producing the items or the components like the clutch lever, they are controlling the dimensions of this clutch lever in such a way that it fits into all other motorcycles again. So that is why we need the interchangeability over there for the parts. It is very important for the parts to be interchangeable for mass production. Then second term over here we can see is tolerance. What does tolerance mean? Tolerance means what are the acceptable sizes. So there is a lower limit for the size of the part and there is a higher limit for the size of the part. So that is defined by tolerance. So the components produced should have a specified tolerance. They should be within a tolerance. They should be higher than the lower limit and lower than the higher limit of the tolerance. So limit, again we have just discussed a little bit. it specifies what is the size you want, the lower size below which the parts are not acceptable, and the higher limit above which the size of the dimension of the part are not acceptable. And then next term is the fits. By fits we understand different kinds of fittings. They can be sliding fit, they can be push fit, or they can be interference fit. So we have to take into account these sizes while we are manufacturing different components. In general, parts that are manufactured in various industries are used to form assemblies. So whatever we are producing may form an assembly. So it should be fitting well in the assembly, and the assembly should be able to work well. It should function all right. So for that reason, we need to control all the dimensions of the parts. For parts and components to fit properly in an assembly, it is important to have interchangeability. For example, many parts are manufactured by Maruti automobiles in Gurgaon, and these are sent across whole India to replace worn out or damaged parts. For these parts to fit well and function properly, all parts need to have high dimensional accuracy. Hence, it is important to control dimensions of components. There has to be a upper limit and lower limit set for geometrical dimensions of these components. The assigning of dimensional value to various sizes of components is covered by limit and tolerance. For example, a part with shaft diameter of 25 mm cannot be of exact size, as this will increase cost of manufacturing. So rather there is an limit made for the component which should be it should be very near to 25 mm size, but it is not exactly 25 mm size, because we don't need to make the exact part, because in manufacturing the exact part there will be a lot of expenses will be incurred for making the dimensions exact. So for that reason we have certain tolerance in the different component dimensions. For example, we can have it 25 plus minus 0.02 mm, which is a tolerance of 40 microns, that is 0.04 millimeters. It will be more sensible to manufacture this part with some tolerance, say 25 plus 0.02 and minus 0.02, which means that the size of shaft has a tolerance of 0.04 mm. Also, it means that all parts have lower limit of dimensions as 24.98 and upper limit of 25.02. So over here we can see that the lower limit has been assigned as 24.98 and the upper limit has been assigned as 25.02. So any part with dimensions over 24.98 and below 25.02 mm will be accepted, whereas any part with dimension lower than 24.98 will be rejected, and any part with size above 25.02 mm will also be rejected. So the tolerance over here is 0.04 mm. All parts manufactured within these limits of dimensions shall pass the quality test. So we have to make inspections time to time. The inspection may be made at time of manufacture while the process is going on for manufacturing, or it may be made after the parts have been produced and they are ready for dispatch, or otherwise the parts may also be inspected while you are buying them. So you have to check all those dimensions of the parts before you buy them or accept them. All parts manufactured within these limits of dimension shall pass the quality test. It is the concern of manufacturers to make sure to produce parts within the specified limits of dimensions. One of the means to ascertain this is by measuring this with help of measuring instruments like vernier caliper. Still easier means of measuring the size may be by screw gauge, but if the parts are manufactured in large quantity, then these methods fail to account for high cost, high level of required skill and larger amount of required time. The solution to these problems lies in use of go and no go gauges. When we use go and no go gauges, all parts with dimensions less than lower limit and dimensions above upper limit will be found easily and rejected in the test. As such, only those components will fall within the tolerance which pass the test. To control the dimension of various sections of components, the method used in majority of work in quantity production is the system of limit gauging. So, gauging is actually a comparison of dimension with another instrument called the gauge, which is of two types, the go gauge and the no go gauge. These are generally made in sets. In a single piece of gauge, you have the go end and the no go end. So, because this is an integral design in which you are having the go and no go gauges on same instrument, so you don't have the worry of losing one part or having misplaced one part which is suitable for the no go side also. This has the advantage that it can be operated in many cases by unskilled workers. So, it is not possible for all the workers to have that kind of a skill or that kind of a feeling in measuring with the help of measuring instruments like the vernier caliper or the screw gauge, and moreover these instruments are quite expensive. For example, the vernier caliper for about 12 inches may cost around 5,000 rupees, and the screw gauge may cost around 3,000 rupees for 50 mm. So, there is a way out to be found for the unskilled workers as well, who can inspect the dimensions of the components at various sections and find out easily whether it is passing the test or not passing the test. Only those parts will be passing the test which are made according to the tolerance, that is the lower limit and the higher limit of the size. Gauges are inspection tools of rigid design without scale which serve to check dimensions of manufactured part. Gauges do not indicate exact value of inspected dimensions of the components. So, this is very important to note that there is no meter or reading over the gauges, only they tell that whether the size is within the limits, whether it passes the test or not. So, the gauges are not actually telling the exact size of the part, but certainly you get for the go side you are able to find out that the part is all right if the go side enters into or over the component where the dimension is being measured, and for the not go side, if the not go side does not enter into the hole which was earlier checked with the go side, that means the part is perfect, it is usable. They only indicate whether this part has been made within the specified limits. The workers do not require making any calculations to determine exact dimension of the component. Gauges are convenient to use and have following advantages over measuring instruments. Number one is no adjustment is necessary in their use. They usually, second point is they usually are not general purpose instruments, but are specifically made for some particular part which is to be manufactured in quantity. So, what is this quantity where we need a go and no go gauges? Suppose we are manufacturing 4 or 5 parts or 10 parts or maximum 20 parts, 20 components. In that case, you can check the dimensions with help of measuring instruments themselves. But if you are making in large quantity, say 1000 pieces a month or 1000 pieces which is again going to have an order after 1 month or 2 months, in that case it is wise to get made a set of go and no go gauges rather than relying on the measuring instruments, because measuring instruments require a lot of skill to use and they are time consuming as well. And another advantage is for using go and no go gauges, the limit gauges, is that lesser skill is required. And another advantage is it takes less time to operate. And last but not the least is the lower cost. For the go gauge and the go gauge and the limit gauges, the cost will be lower. Plain gauges are used in checking plain, that is unthreaded holes and shafts. So generally we are using plain gauges for measuring of the components, because most of the dimensions where the places we are taking dimensions are the plane surfaces. It may be a hole or it may be a flat surface, a set of flat surfaces, a slot having two flat surfaces, or a hole which may be of round geometry, it may be a square geometry. All these we can measure with help of limit gauges. So next we come on to classification of plain gauges. So we will be discussing over here what all types of gauges we have for our industries. So classification may be done, number 1 according to type, number 2 according to purpose of measurement, number 3 according to form of tested surface, and number 4 is according to design. So we will be discussing first of all according to type. So number 1 gauge is the standard gauges, and number 2 is limit gauges. In the standard gauges, what we have is that the size of the part to be produced is exactly same as the gauge. Standard gauges, every gauge is almost opposite copy of part that it measures. For example, if bushing is to be made to assemble with shaft, then the gauge for bushing will be a shaft of same size. So in this figure we can see a standard gauge. The part to be produced is this one on the left hand side, the mating part, which is having a dimension of 50.1, and it has to be fitted into this bush over here, which is 50 mm size hole, which means or indicates that this hole is smaller than the mating part. So that means it is an interference fit. So in this case, if we make a standard gauge which is replica of mating part, it is same as the mating part. So over here we have the same size as 50.1 mm. So this type of standard gauge is not of any use for this kind of a testing, because this cannot enter into the hole. So that is why this limitation is there in the standard gauges, and that is why we avoid using standard gauges and rather we go on for some other system of gauges. If a gauge is made as exact copy of opposed mating part, it is called a standard gauge. The first standard gauges were the opposed mating part itself. However, such individual fittings are not convenient for or practical for large scale production. Moreover, the parts that are to form assembly may be manufactured at different plants. Hence, it is better to use a checking tool gauge rather than opposite component itself. However, such standard gauges have the following disadvantages. The quality of manufacturing will be dependent upon freedom of mating of component to standard gauge. It will be difficult for different workers to understand and maintain this mating freedom. Example, slide fit or loose fit. Then another type is a standard gauge another reason is a standard gauge cannot be used to check interference fit as shown in the diagram 1, which we have just discussed the figure number 1. So, we find out over here standard gauge is not solving the purpose. Then another classification for these gauges is the limit gauges, which is more acceptable and widely used in the industries. The system of limit gauges is very widely used in industries. The gauges are made